Let's write prime factorization. Whoever's popping, please stop. Now, before we get into too much, there are a couple words you're going to need to know. You're going to need to know the term prime or prime number. What is a prime number? Anybody know? Basically, I mean, the correct definition would be has only one set of factors, one in itself. Okay? So there's two different ways you're going to write that. Okay, so it has only one set of factors, one in itself. What does that mean? That means that can only be divided by itself. Okay, so it has only one set of factors. That set of factors is one in itself. What does that mean? It means it can only be divided by itself. Shayna.
What is that last word on the top?
Itself.
Oh.
The second word you're going to need to know is composite number. A composite number has more than one set of factors. Autumn? Okay, it has more than one set of factors. What does that mean? Can be divided by something other than itself. Now, let's get out your once you get this written down, get out your calculators real quick. And let's say I gave you the number 21. Huh? What?
You said the 10 I gave you maybe 21. But are you giving us the number 21?
Yes, let's say we had the number 21. On your calculators, can you take 21 divided by 2? I mean, you can always divide it by 1, right? But can you take 21 divided by 2?
No.
Does it work out evenly?
Should we try?
Now, take 21, it doesn't work out evenly, it works out with a decimal. Okay? Take 21 divided by 3. Can you divide 21 by 3? Yes, you get 7. So, is the number 21, is it a prime or a composite number? Composite, because you can divide it by something more than 1 or itself. Let's take the number 51. Can you divide 51 by 2? And right away you should know you can't because it's not an even number. Can you take 51 divided by 3?
Yes.
Yes. You get what?
17.
17. So is 51 a prime or composite number?
Composite.
Composite. Take the number 17. Can you divide 17 by 2? No. Can you divide 17 by 3?
No.
No. Can you divide 17 by 4? No. Can you divide 17 by 5? No. 17 divided by 6?
No.
No. 17 divided by 7?
No.
No. 17 divided by 8?
No.
No. 17 divided by 9?
No.
No. 17 divided by 10?
No.
17 divided by 11?
No.
Divided by 12?
No.
13?
No.
14?
No.
15?
No.
16?
No.
17?
Yes.
Yeah, you can divide 17 by 17. But that's the only thing you can divide it by. So the number 17, is 17 a prime or a composite number? Prime, because it can only be divided by 1 or itself. Okay? So that's how you can use calculators to figure out if a number is prime or composite. Okay? Now, something you're going to have to do is, at some point, you're going to take the number, let's say, 24. And if they ask you to list the factors of 24, anytime they ask you to list all the factors of a number, the first set of factors, can you divide 24 by 1? Yeah, you get 24. The first set of factors of any number is 1 in itself. So what we do is we make it like walls. Okay? The smallest possible number is 1. In this situation, the largest possible number is 24. Now, can we take 24 divided by 2?
Yes. Yeah.
Yes, 24 divided by 2 is 12. So the next set would be 2 and 12. Can we take 24 divided by 3?
Yeah.
Yes. 24 divided by 3 is 8. Can we take 24 divided by 4?
Yeah.
Yes, we can divide 24 divided by 4 is 6. Can we take 24 divided by 5?
No.
No. Can we take 24 divided by 6?
Yeah.
Yes, you get?
4.
Now, we already have that set. So right here would be all the factors of 24.
What about 20?
Okay, now, let's say we list the factors of 36. The first set of factors of 36 would be what?
1.
1 and? Factors are always in sets, always in pairs. 1 and 36. So the 1 is the smallest number, the 36 is going to be way out here. We set up the walls. Okay? I think last year we talked about this. Okay? Whenever I was your age, there was a cartoon and the walls would close in. Okay? So we have now set the walls. Can we take 36 divided by 2? 36 divided by 2 is? You have calculators. 36 divided by 2 is? 18. So now we have 2 and 18. The walls have closed in. Can we take 36 divided by 3? Yes, 36 divided by 3 is? 12. And the walls have closed in even further. Can we take 36 divided by 4? Yes, you get 9. So 4 and 9. Can we take 36 divided by 5? No. Can we take 36 divided by 6? Yes, that is? We only have to write the 6 down one time, but since it's a 6 and a 6, it's tight together. There's no other possibility. And so here would be all of our factors of 36. Okay? Now, today what we're going to work on, though, that is factoring out. Today what we're going to work on is we're going to work on prime factorization. We're going to take a number and we're going to break it down into all prime numbers. Okay, so the first thing you're going to do when prime factorization, you're going to break the number into a set of factors. Other than 1 in itself. Okay? We don't want to break the factors into 1 in itself because we have not done anything. The next thing we're going to do is we're going to break those factors we're going to take the factors from step 1 and we're going to break them into a set of factors. We're going to continue breaking the numbers down or breaking the factors down until they're all prime numbers. So continue breaking the factors down until all prime numbers. And then finally, the last thing is you're going to write the prime numbers in exponent form. Okay, so example, and put this example in your notes. Let's take the number 24. Now we can take any of the set of factors that we have listed up above. How do you want to break 24 into? We can break 24 into what set of factors? Owen? 4 and what?
6.
It has to be 2 numbers. Okay, it has to be a set. So we're going to take 24, break it into 4 times 6. Now, step 2, break those factors from step 1 into a set of factors. Can we break 4 into anything? 4 can be broken into what, Evan?
2.
Has to be 2 numbers. Well, has to be a set, has to be 2 numbers.
Oh, 2 times 2.
4 breaks into 2 times 2. Can we break 6 down? Shayna?
3 times 3.
Huh?
3 times 3.
That's
9.
9.
Oh my God, 3 times 2.
6 can break into 2 times 3.
Doesn't have to be 2 times 3.
It don't matter. 3 times 2, 2 times 3 makes no difference. Now, we want to put a multiplication sign in there. Can we break the 2 down to anything?
Yeah.
We break the 2 into 1 times 2, right? But we don't want to break it down into something that is something other than 1 in itself. So can we break the 2 down to anything?
No.
No. Can we break this 2 down into anything?
No.
Can we break the 2 down into anything? Can we break the 3 into anything? What?
No.
No, nothing. These are all prime numbers. Now let's check it. 2 times 2 is? 4 times 2 is? 8 times 3 is? Okay? These will always, when you multiply them, will always equal that. Now, let's take the 24 again. Let's say you didn't break it into 4 times 6. Let's say you broke it into something else. What else can you break it into? Dakota? Well, it's the same numbers. Steph?
8 and 3.
3 times 8. Can we break the 3 into anything?
No.
No. Can we break the 8 into something?
Yeah.
The 8 breaks into
2 and
2 times 4. Okay, so the 8 breaks into 2 times 4. Now, what I want you to do, we're not going to leave this 3 up here by itself. So we're simply going to bring that 3 down. It doesn't break into anything. Okay? Now, can we break the 3 in anything? Can we break the 2 in anything? Can we break the 4 in anything? What does 4 break into? 2 times 2. We're not going to leave these 2 and 3 up here by themselves, so we're going to bring the 2 down, and we're going to bring the 3 down. And now we have 3 times 2 times 2. Same thing, right? 3 times 2 is 6. 6 times 2 is 12 times 2 is 24. Now, we broke it down in different ways, but it still broke down into the same thing. Now, I said about we're going to put it into exponent form. If we want to put this in exponent form, based on your homework you did today, how would you write 2 times 2 times 2 times 3 in exponent form? Landon?
Would you put 2 and then a 3?
Yep, 2 cubed because there's 3 of them. 2, that's the base, it's being multiplied. 2 cubed because there's 3 of them.
And then times 3?
Times 3, times this one out here. This thing here. How would you write that in exponent form, Dakota? The same way, because in exponent form it's the same thing. Now, if you wanted to, you could say it's 3 times 2 cubed, but it means the exact same thing. Okay? And so that is taking a number and put it in what we call prime factorization. We have broken it into prime numbers, and then we wrote it in exponent form. Declan. It's an emergency.
Is that how you want us to solve them?
Absolutely. Okay? Get your whiteboards out. Okay, on your boards. Do the number 36. What can you break the 36 into? Do it on your board.
Should we solve the whole thing?
Just do it one step.
Okay.
You don't want to see it. Okay? Oh, Shana, you didn't break it down into anything. We're going to make a tree out of it. We're going to make it like a Christmas tree. We're going to just keep on spreading it out. It's going to be like a perfect Christmas tree. It's going to be symmetrical. Okay, so. Other than 1 in itself, Shana. Break the number into a set of factors other than 1 in itself, because you still have the 36 there. So, how do you break it, Steph?
6 times 6.
6 times 6. Can anybody do it a different way? Dakota? 9 times 4. Anybody do it a different way?
I originally did, and then you said you wanted us like a perfectly symmetrical.
What'd you use?
I did 2 and 18.
Okay, that's fine.
but make it longer. But now I change. I'll just keep it like that.
Okay? Now, I want you to break these down. Break each of those factors down. Question, Owen?
More marker. Joan, you still get
Okay, Joan. You still
it.
Okay? Let's check it one. We break the 6 down. 6 breaks into 2 times 3. I always put the smaller number first for whatever reason. Can we break that 6 down? Yeah, it breaks into 2 times 3. Now multiply those. If you do it this way, can we break the 4 down? 4 breaks into 2 times 2. Can we break the 9?
Yeah.
Breaks into? If we did it this way, can we break the 2 down? No. Can we break the 18 down? 18 breaks into? 9 times 2.
That's what I got. 6 and 3.
Okay, 2 times 9. Someone said 3 times 6. That's fine. Okay, we're not going to leave this 2 up there by itself, so we're going to bring that 2 down. Now, can we break this 2 any farther? Can we break that 3 any farther? The 2? The 3? No, we're done with that. For this one here, can we break the 2 down? 2? 3? 3? No, so done with that one. With this one, can we break the 2? 2? 9.
Yes.
9 breaks into? 3 times 3. Now I'm going to bring that 2 down and bring that 2 down. So we can't break them down anymore. Now we're going to put it in exponent form. Are there any numbers that repeat? What? How many 2's are there? 2. So this would be 2 squared. Are there any other numbers repeat? And that would be 3. How many 3's are there? 2 of them. So 2 squared times 3 squared. Are there any other numbers? Now, if we look at this one, are there any numbers that repeat? Yeah, the 2. How many times? 2. The 3? Yes. How many times? 2. Here, any numbers repeat? Yes, the 2. How many times? 2. How many 3's? 2. So it didn't matter how we broke it down. Prime factorization is the same. Prime factorization is the same no matter how you break it down. Okay? Question. Do this one. 18. Do this one all on your own. Do a factor tree of 18 and put it into exponent form. What? Okay. You don't need to do that. We haven't done that at all with these, okay?
Seems like it always breaks down to 2 and 3. Wouldn't it have to actually?
Let's see, okay, you want one that doesn't?
Huh?
We'll do one that doesn't. Put it in exponent form now. You don't need to put an exponent one. It's not wrong, but you don't need to put it. Anytime there's an exponent one, you don't need to put that. Check your data. Check your exponent form. Dad, let me see yours. You're missing something there. Okay, so I see 2 different ways we can break the 18 down. I saw some that had 3 times 6, and I saw others that had 2 times 9. Either way is fine. Now, if you did the 3 times the 6, can we break the 3 down? No. Can we break the 6 down? Yes, 6 breaks into 2 times 3. And then we need to make sure we bring that 3 down. Is there anything else we can break these down? Can we break the 3 or 2 down? No, they're prime numbers. This one, 2 and 9. Can we break either of those down? The 9 breaks into 3 times 3. We bring that 2 down. Now, can we break any of them down? No. So now the last thing we need to do is put them in exponent form. Are there any numbers that repeat? Yes, the 3. How many times? There's 2 of them. So there's the 3 squared. Now we have to make sure that we include the 2 as well. Okay? We have 2 3s and 1 2. Same thing over here. We have 2 3s and 1 2. Now, Evan said, I think it was, does it always break down into 2s and 3s? Okay? Here's an easy one. 25. Make a factor tree of 25. What can we break the 25 into? 5 times 5. Can I break either of the 5s down? No, they're prime numbers. An exponent form would be 5 squared. Okay? How about this one, class? Make a factor tree of 51. Now, stop 1 second. Is there anything we divide 51 by? If you're not sure, what can you do?
Calculator.
Use a calculator. See if there's anything you can divide 51 by. Don't say anything. If you use a calculator, make a factor tree out of 51. What did you do?
I did 50 times 1.
That doesn't equal 51.
50 times 1 is 51.
50 times 1 is 50.
They gotta go at home.
How do you use your calculator to do this?
It's a
Quiet. How do you do 50? How can you use a calculator to break 51 down?
Because instead of just writing each problem down, you can just type it in.
Take 51. Everybody get your calculator out. Take 51 divided by 2. Does it work out evenly? No. Take 51 divided by 3. Does it work out evenly? Yeah, equals what?
17.
So that means that 51 breaks into 3 times 17. Now, can we break the 3 down into anything? No. Is there anything we can divide 17 by? No. So right there, that would be prime factorization, 3 and 17. Now, do we need to put it in exponent form? No, because there's only one 3 and there's only one 17. But that's how you can use a calculator.
So we got it right. So it would be.
Okay? It would be 3 times 17. Any questions? Okay, so tonight for your homework, as I was saying, tonight for your homework, there's going to be a couple problems that they're going to ask you to list all the factors. There's also going to be questions that's going to ask you if they're prime or composite. And then there's going to be problems that are going to ask you to do prime factorization in exponent form. So you're going to have 3 different types of problems. Problem type 1, type 2 is decide if it's prime or composite, and type 3, put it in exponent, do prime factorization, put it in exponent form. You'll see. Okay, so your homework, page 96. Six to 24 even, 28, and then 34 to 38. Yes, you can use calculator.